0.6 ounces or more in it. A little issue comes when you want to see if something has increased or decreased. Okay, so let's say we have a car that gets 24 miles per gallon. Now they've put something new, they've changed something in it, and they want to see if that change has improved my gas mileage. Okay, that means they want to know, does it now get more than 24 miles per gallon, right? That's what improve it. I now get 26 miles per gallon, 25 miles per gallon. I cannot test that directly. It's kind of like you can't prove a negative. You can't prove you didn't do something. Someone has to prove you did something. So we cannot test something that doesn't have an equality. Okay, so that this is what we want to know. Is mu greater than 24? I can't test it. But I can test the opposite. I can test, is mu less than or equal to 24? So if this new system works, my final step 7, which is my decision step, if this system really works, in step 7, I would reject the null hypothesis. Because if I reject the null hypothesis, I have to think the alternative is true, right? If I reject the null hypothesis, I think this is true. I think mu is greater than 24, then I do get better gas mileage. Okay, so you have to remember for your multiple choice, the stupid answers will be anything where the null hypothesis does not have an equal sign in it. So if it says the null is mu greater than 24, you don't even have to read the question. Absolutely impossible for an H sub naught here. This is a null hypothesis. This has got to have an equality. This is a less than or equal to. This is a greater than or equal to. This is a plain old equals to. There's got to be an equals in the null hypothesis. Okay? Because that's what you can test. Alright, so if you're claiming greater than or equal to, like I am over here, okay? So Colton's 20-ounce soda, so they're claiming that it's got 20 ounces or more, right? How can I prove them wrong? If I get what? A number, what kind of number? A number higher or a number lower? How do I prove them wrong? Lower. If they get something down here, right? If I get something less than 20, I might be able to prove them wrong. Do you agree? We submit, we don't know what it is. We don't know what this number is, but we know 18.6 will probably be low enough for us, right? But there's some number here. Okay, even if I get 19.999, okay, that's not 20, but it's probably not statistically significantly different enough. I need to find this cutoff point. What number makes it statistically significantly different? And if I get a number down here, I'll be like, fine here. If I get something in here, I'm like, suspicious. I'm suspicious, but I don't have proof beyond a reasonable doubt. I also saw something on TV. So a lady got arrested for killing her husband and her brother. They've been suspects for 30 years. And they just went to court and were found guilty 30 years later. Okay. She'd been in this range for 30 years. Now she's down here. They had evidence beyond they found some new, I'm sure, DNA, something evidence that they found that they could test. So here you're suspicious. Here, you are good to go. I got 21 ounces. Oh, you are stellar. Okay. Here, I'm suspicious. Here, this is beyond a reasonable doubt. Okay. Here, you're guilty. Here's the guilty. Here's the, you're definitely fishy. Here, you're good to go. But you know, in court they don't usually say, occasionally they say you're innocent, right? People, they've been in jail and they do DNA testing and they realize that they didn't do it. But they don't usually, when my jury duty that I did at the beginning of the semester, and he was found not guilty. He was found not guilty. They didn't say he didn't do it, but he was not guilty beyond a reasonable doubt. Right? That's the difference. So here's the suspicious, here's the beyond a reasonable doubt. We're only going to fine him if we can get him down here beyond a reasonable doubt. So the only way if they're claiming that there's greater than or equal to 20 ounces, the only way I can prove them wrong is if I get something way down low, right? Statistically significantly different down low. And down low here, this is called a left or a lower tailed test. And it's a one-tailed test because I only care this way. Okay, so I tell students, look at the sign of the arrow in the alternative hypotheses. That's pointing the way the test is. Because the alternative is if you reject it, right, and you believe the opposite. That's how you can prove your null wrong, is by making your alternative right. Now, this one is also a one-tailed test, okay, but it is a right tail. Okay? And this means it's a two-tailed test. You care both ways, lower and upper. You care both, right? But always, there's always an equality of some kind in the null hypothesis. So what you've got to look for when you read questions to determine which type it is, you're going to look for keywords. This is like at least 20 ounces, right? This was improved more than 24 miles per gallon, right? So more than 24 miles per gallon was this one. So let's have here's a lower tail. Okay, so I'll draw them for you, the ones that we had talked about. So a lower tail test, that means the rejection region where you're going to be able to disprove the null hypothesis. Well, right, remember we can always make a mistake because we're doing samples. Okay, so this was, in our example about the 2-liter soda, right? They claimed there was at least 67.6 ounces. The opposite was mu was less than 67.6 ounces. This is a left-tailed test. When it's a greater than or equal to or less than or equal to, I know it's a one-tailed, and equals is two-tailed. Okay? But I'm able to prove this wrong if I get something. And so the kind of tail it is where your rejection region is. Okay, so this is a left or a lower tail. I say left usually, but a left or a lower tail is your rejection region. An upper tail, so this was like the question where we were trying to see if mu was greater than 24 miles per gallon. And the opposite of that is mu is less than or equal to 24 miles per gallon. The equal sign has to be the null hypothesis, and the other one's the alternative. This is the alternative, right? And so if we're testing 24 miles per gallon or lower, the only way I can prove them wrong is if I get 27 miles per gallon, for example, correct? So this is a right or an upper tail test. Again, it's the way the arrow is pointing in the alternative hypotheses. If I got 25.01, I probably won't be able to have enough evidence to reject the null hypothesis. With the example about the 2-inch screws, okay, then this is the null hypothesis because it's got the equality. This is the alternative. Here's 2 inches, okay? They want it exactly 2 inches. So this is why this is a two-tailed test, because we would have a rejection region here and a rejection region here. Okay. We also get to decide how confident we want to be. In chapter 8, when we did confidence intervals, we talked about 90% confident, 95% confident, 99% confident a lot of the times, right? And with confidence intervals, we always looked up the z or the t for alpha divided by 2, didn't we? Because we were always looking for the middle 95%, let's say. Because that's what a confidence interval is where's this middle 95%. And that's still what we're doing when we do a two-tailed test. We're still splitting the alpha between two ends. But here we're not. Here we put all of alpha in the right tail, and over here we put all of alpha in the left tail. So as I said, you've got, when you read the question, you're looking for those clues, words like increased, decreased, at least, more than. Those are key words that you're going to be looking for to help you come up with writing your null and alternative hypothesis. Okay? All right, so I'm going to pull up the book, and we're going to just practice this writing the null hypothesis, which is actually the first 3 steps of the 7-step process. Okay? So I will out of here. I don't think all right, we are Thursday. This part's going to go so fast this next month and a half. All right, here's the first question. The manager of the Danvers Hilton Resort Hotel stated that the mean guest bill for a weekend is $600 or less. A member of the hotel's accounting staff noticed that the total charges for guest bills have been increasing in recent months. The accountant will use a sample of future weekend guest bills to test the manager's claim. Which form of the hypotheses should be used to test the manager's claim? First one?
Yeah.
Why do you think that?
Because the claim is that it's 600 or less, so.
So what does 600 or less mean?
Second row. Yeah, it's middle.
Oh, middle one, yeah.
The middle one. Okay, so the or less, you picked out the very key words, right? And that's what, on your exam, I like to see some of you were highlighting stuff and circling the important words. The important words here, right, or less. Okay, so 600, what they said is, he's saying that the mean is less than or equal to $600, right? So step 1 is write down, what do you want to know? Because he's testing the manager's claim, right? Or what do you want to know, or what's the claim? What do you want to know? Or what is the claim? Okay, so he's claiming this. Step 2, write down the opposite so that they're mutually exclusive and collectively exhaustive. What's the opposite? Greater than 600. Okay? And then step 3 is to label them. Which one is the null and which one is the alternative? Which one's the null? Is it the null because it's the step 1?
No.
It's because it's got the equality. Because it's not always, right? Sometimes we can't test what we want to test. We have to test the opposite and then arrive back at what we want to know. So in B it says, what conclusion is appropriate when, so remember I'm going to teach you, this is my Who Shot JR, tempt you to come back to class. And I'm going to teach you 4 through 6 later. It's a cliffhanger. Okay, but I'm going to tell you that so step 7, I'm kind of telling you the answer, the whodunit before I tell you how. This is your final answer, your final decision. Are you gonna reject the null hypothesis or not? Okay? Are you gonna reject it or not? So in B it says, what if you say, I do not reject the null? And the null is mu is less than or equal to 600, right? So you do all this work that we're going to learn about later, and then you say, okay, I do not have enough evidence to reject the null. Then the accountant can't prove the manager's wrong. It could be that the accountant did a study and he got a mean of $597, right? And he could have been like, oh, I'm wrong. But it could be that the accountant did a study and got a mean of $601.72. And even though he thinks he's right, that difference of $1.72 is not, what are the words? Statistically significant enough for him to reject the manager's claim, right? Because you can't just be a little bit more. That's in the suspicious range. You've got to be statistically significantly different. So if you do not reject the null, then you would not be able to disprove the manager's claim. What if you can? What if you do reject the null hypothesis? So if you reject the null, you can disprove it with your work. If you reject the null, then you have to think that mu is greater than 600 and that the bills have been increasing. Does that make sense? Okay, so let's look at number 2. You're going to write it yourself. Okay? The manager of an automobile dealership is considering a new bonus plan designed to increase sales volume. Currently, the mean sales volume is 14 automobiles per employee per month, right? So you all work at my car dealership, and on average, you all sell 14 cars every month. I currently pay you $2,000 each, okay? The manager wants to conduct a research study to see if a new bonus plan will increase sales. So let's say I'm going to, instead of giving you $2,000, we're going to test a new way. You guys, I'm going to give you $1,000 a month plus $75 for every car you sell. And I want to see if we can increase our sales, right? Isn't that what I want to do? You guys are going to stick to your $2,000. You're going to average 14 cars. I'm going to see if this new method will make my sales go up, right? Because the manager wants to conduct a research study to see if the new bonus plan increases sales volume. To collect data, a sample of sales personnel will be allowed to sell under the new plan for a 1-month period. Got it? A says, develop the null and alternative hypotheses most appropriate for this situation. So try your steps 1, 2, and 3. Word here that will tell you if it's a 1 or 2-tailed test and if it's a 1-tailed left or right. What's the word?
Increase.
Mm-hmm. This is your word. So the manager wants to know if mu is more than 14. Isn't that what they wants to know? He wants to know, you guys gonna sell more than 14 cars each with this new system? Because I'm paying you for every car, you might work harder, right? You might sell 20 because you make more money. Okay. What's the opposite of that so that it's mutually exclusive and collectively exhaustive?
It's not.
Got it? That's the opposite, right? So that it's mutually exclusive and collectively exhaustive. Which one is the null hypothesis and which one is the alternative?
The first one? First one is it.
Why is that the first one?
So,
Because it's got to have an equality in the null hypothesis. So in this case, this is what the owner or the manager wants to know, but I cannot test that. So I'm going to test this, right? If I'm right, let's say you guys end up averaging 20 cars. That's statistically significant. What would be my step 7? Reject or not reject? If they end up selling 20, isn't this one true? Right? That's true. This is not true. I would reject the null. That mu is less than or equal to 14. Right? The new bonus plan works. Right? And you guys, you're all switching to that method. You now are going to $1,000 because I just proved it worked with you guys. Then I'd switch everybody over. Now it could be this was an anomaly, right? Again, because I only did a sample, I could be wrong. It could be down the road I figure out, no, the average stays at 14. It didn't really, you know, if I put you all on the plan, I'd find out, right? What if I did a study and I got, you guys averaged 14.1 cars each? And I'm like, well, it looks like it went up. But it's not statistically significantly different enough. Then I would not reject the null, right? If I got 14.1, I'd probably not reject the null. And you guys would all go back to the old method of just getting paid $2,000 a month. Right? If I can't reject the null, I think that the bonus plan didn't work. Right? Does that make sense? So you got, now let's say on a test you did these steps wrong. You made it a 2-tailed test instead of a 1-tailed. You made it left instead of right. You will lose some points on there, but then I will work the rest of the steps based on the way you wrote your null. If you did the rest of the steps correct for the way you wrote your null, you will get all the future points. Okay, so I will follow through with whatever. That's why I want you to show me your work so I can follow along. So could I be wrong? Of course, right? I keep telling you whenever you take a sample, I could be wrong. Sometimes I find out that I'm wrong, okay? If I switched everybody to the new bonus plan and all of a sudden your mean's 13.5, I'd be like, oh my God, I was wrong. But if I didn't switch you, I would never know if I should have switched you, right? If I did this test, I got 14.1, I'm like, oh, no, let's all go back and we'll just get paid the old way. I would never, ever know if it really would have worked. So sometimes when you make an error, right, because whenever there's a sample, there's error, sometimes you find out your error. Okay? They did that in the last presidential election. They made a call. Most people made the call wrong, and they found out when the election results were published, so we were wrong. But there's sometimes when you make a decision, it's usually when you make a decision not to do something. If I say, hey, Colton, go study this town, should we open a store there? And he comes back and says, no, we shouldn't. I'm like, okay. He could have been wrong, and I would never know because I never opened a store there. What I would know is if he comes back and says, yeah, let's do it, and I do it and it fails, then I knew he was wrong, right? So you usually don't know your error if you decide not to do something, if you never get all of the data. But you do have to know that that is a possibility. I know if I didn't open a store, there's a 5% chance it could have been fabulous, right? So we get to decide how sure we want to be, so there are errors that we can make. They're called a type 1 and a type 2 error. You can't make both. You can only make one. You make a type 1 error only if your decision is to reject the null hypothesis. So if you reject a null hypothesis, your error is you shouldn't have rejected it, right? So if, by definition, if you've made an error, you've done the wrong thing. So you can only make a type 1 error if you reject the null, and the error is you shouldn't have rejected it because it was true. That will happen alpha of the time. You, as the person doing the experiment, decide what alpha is. You want to be 95% sure, then what's your alpha?
5%.
5%. Okay, you want to be 99% sure, what's your alpha? 1%. You get to decide what your alpha is. Okay, and that your alpha is the chance of rejecting a null hypothesis that's correct. A type 2 error is accepting a null hypothesis when it's wrong. Okay? So you accept the null, but you shouldn't have. That's a type 2 error. Okay? A type 2 error happens what's called beta of the time. We're not going to calculate it, but you will learn about it later in your higher level business classes. Okay. But if the null is true and you don't reject it, that was the right thing to do, wasn't it? Right? The null is true. Your decision is don't reject it. You will do that 1 minus alpha of the time. So 95% of the time, 99% of the time, you will do that correctly. If the null is true, but your decision was to reject it, that means you made a mistake. It's called a, what kind of error? Type 1. Okay, you made a type 1 error, alpha of the time. Okay, so if the null is true and you reject it, you might never know you made it. You just need to know there's a 5% chance I did it wrong. If the alternative is true and you decided to reject the null, that was the right thing to do. You should reject the null because then you think the alternative is true and it is true. That happens 1 minus beta of the time. And if the null is true, if the null is not true, okay? If the alternative is true, but you accept the null, that's a type 2 error. Now, based on the next slide, I think, let's make a big circle on it. No, it's on the next slide. I'll take care of this one. I'll come back to that one in the next class. So this is how you avoid a type 2 error. You can avoid a type 1 error. It will happen alpha of the time. This is how you avoid a type 2 error. Instead of saying, I accept the null, if you write, I do not have enough evidence to reject the null hypothesis, that's not wrong. Even if you should reject it, you just don't have enough evidence to do so, right? And that way, I said it sounds a bit Bill Clinton-y, but it's like a play on words, like a legal loophole. But instead of saying I accept the null, just say, your evidence that you've gathered is not enough to reject it. So it's just say, I don't have enough evidence to reject the null beyond a reasonable doubt. It's not saying that it's like when we say that they're not guilty. We don't usually say you're innocent. We just say you're not guilty beyond a reasonable doubt. And that's different than saying you're innocent. And that's the same here. We're going to say, I don't have enough evidence to reject it. Then I'm not wrong. There's no error there. I don't have enough evidence. I'm not saying it's right. I'm just saying what I have is not enough to reject it. Okay? So we will come back next class and talk a little bit about type 1 and 2 error. And then we'll go learn about steps 4 through 6.